Hey, welcome back. In my last video, I went over on how to finish up your requirements by specifying your project motions. Today, I will be talking about the third step, how to research parts for moving project, part 1. There is a lot of stuff in here, so this step is also split into parts. Last time, we derived motions from our motorized scooter idea. 1. Move forward from A to B, which is linear motion. 2. Be able to make right-hand and left-hand turns, which is rotational motion. 3. Have a freely rotating handlebar, which is also rotational motion. So how do we pick the right parts for these? Well, your part selection will be different depending on your motion type. For manual projects, the selection process is straightforward. 1. If your motion requirement is linear, then pick a part or parts that can fulfill linear motion. 2. If your motion requirement is rotational, then pick a part or parts that can fulfill rotational motion. What does that mean? It means if you want linear motion, then pick a part or parts that can output linear motion. Same for rotational. Pretty simple, right? Well, not quite. The thing is, there are a lot of parts that can move in a line, and there are a lot more parts that can move in a circle. Not to mention that there are even more parts that can fulfill both if used a certain way. Hell, you can even make your own parts if you want, thanks to the advent of the 3D printer. So how do you know the exact one to pick? The first thing I try is this rule, the one-to-one match. Remember in the last video where I classified some parts as linear or rotational? You can do a one-to-one match with most parts this way. That is, matching a linear part with a linear motion or a rotational part with a rotational motion. Now do keep in mind that this rule doesn't work all the time, especially when it comes to efficiency with certain requirements. Personally, I find that this rule works well for simple projects with simple motions. It doesn't really work well with projects where single derived motion has to be fulfilled with multiple parts. The second thing I try is this, the motion transfer check. Basically, are there any parts that can change the linear motion to rotational or vice versa? This is worth checking for because motion transfer opens up even more parts for you to potentially use and gets you thinking about how to achieve your derived motions with multiple parts. A huge part of being able to do this is to know about hardware. From that point on though, it becomes project specific. A part can be a perfect fit for one project but be terrible for another. Experience also plays a role. The more you know on what's out there in terms of parts, the better you will be in selecting the right part for the project. Well, how do we get there? For a complete beginner, I highly recommend taking a trip to a hardware store and seeing what they have in stock. If you can't afford the trip, no biggie, the store doesn't have to be physical. By seeing what's out there, you can read up on what each part does and if it seems like a match for your project. Once you have read up, then pick and buy some. Really, the best way for you to learn is to get your hands on it. For automatic projects, the selection process is a bit different. The rule is motors, just motors. What? What are motors and why are we using them? I'll cover and explain them later, but for now just know that they are the most efficient way of doing both rotational and linear motion if you have a power source available. There are tons of information about motors that I won't be able to cover here, so keep an eye out for future videos. Okay, let's do an example, our motorized scooter. Well, a motorized scooter means it's an important automatic project, so we can just pick some motors and call it a day. Now there is a way to pick the right motor, which I will cover in another video since it is a very important process. Since automatic project part picking is very apparent, let's try it for a manual one instead. Here are requirements. So, can we do a one-to-one match on any of these motions? We can for the third one because a freely rotating handlebar can be done with one part. Here, I would pick a 360-degree hinge, like this one. I would use the same one for the second one, since if you look at the actual design, turning coincides with a freely rotating handlebar. Now for the first one, the one-to-one rule doesn't quite work here since there isn't a linear motion part that matches well. Okay, then time for the motion transfer check. Can any part transfer motion to linear? Yeah, there's one actually. I bet you know what it is. Wheels. Our parts list are then wheels and 360-degree hinges. This is all very thought-intensive, so don't worry if you end up spending a lot of time here. The only reason why we were able to run through this so quickly is because scooters already exist and you have me helping you. This process takes more time with something completely new, and especially if you're looking at your first project. The research step is the longest and most important one, so take your time. In part 2, I will go over on how to put the parts you picked together. If you like this, subscribe, let me know what you think in the comments below. Feel free to throw some suggestions too. Thanks!